So in this question, we're given a number of forces, and we're told that the particle upon which the forces are acting is in equilibrium. That means the forces are balanced. It means that the sum of these forces is equal to 0. Okay, so that symbol there means the sum. So if you add all these vectors together, the end result should be 0. So that doesn't mean we add the 5,000 and the 8,000 and the 4,000, but we add them as vectors. So we say the summation of the forces is 0, but that means that if you add the forces in the horizontal direction, the result is 0. And if you add the forces in the vertical direction, the result is also 0. So in the horizontal direction, in the x direction, it looks like we only have one force, the 5k. But actually, each of these forces will have a component in the horizontal direction. So if you look at this 8k Newton force, that will have a horizontal component there. That is simply 8,000 multiplied by cosine of that angle, because it's the adjacent side. And because it's to the left, and our convention is positive x to the right, that will be negative. So we can add all these together. We can say 5, that's positive 5, minus 8 cosine, that's that component there. And here again, it's to the left, so it's minus 4 cosine 60. And the final force is this, and this, the F that we're trying to find, the horizontal component is to the right. So it'll be plus F. And I've written sine theta because this horizontal component is now opposite the angle. Whereas here, it was adjacent to the 60 and adjacent to the 30, so we used cosine. Here, this horizontal component is opposite, so we say F sine theta. So here we have one equation. And because we know cosine 30 is root 3 over 2 and cosine 60 is half, that boils down into a single number that we can move to the other side, and that gives us our first equation. Okay, so we now know a relationship between f and theta. It's not enough to find f or theta because we have two variables, but that is our first equation. Next, we look at the summation of the forces in the y direction. So it's these components. So I've rewritten that there. And again, I'm going to say positive y is positive y is positive in the upwards direction. So it'll be a positive 8 sine theta. Sine because this component now is opposite the 30. And here, the vertical component will be opposite the 60, so it's sine 60, but it's negative because it's in the downward direction. And for the f, the vertical component is adjacent to the angle, so it's negative f cosine theta. The sum is always equal to 0 because we said that's the property of equilibrium. So sine 30 is half, sine 60 is root 3 over 2. Rearrange, that'll give you a second equation. So you have your first equation here, second equation there. How are you going to solve these two equations simultaneously? Well, if we were to divide this equation by that equation, the f's would cancel out, and we'd have sine over cosine, which conveniently gives us tan. So sine theta over cosine theta is tan theta. And then you can find theta by taking the inverse tan of that in degrees. So make sure your calculator is in degrees. So that will give you 82.2. Now you know theta, you can insert that either here or there, and then rearrange to find f. So that theta I can simply substitute into equation 1, and then divide to give me the value of f. So the modulus of f, or the magnitude of f, is 3.96 kilonewtons, and the direction of f is 82.2 degrees with the vertical axis. So that's how you would solve a question like this. You would resolve all the forces into the x and y components, and then form two equations and solve simultaneously. I hope you found that helpful.